Good morning, everyone, and welcome to this, our second East Coast Hydrogen webinar. My name is Sally Brewis. I work for Cadent, and I'm Head of Regional Development for the Eastern Regions and North London. So East Coast Hydrogen is a collaboration between Cadent, Northern Gas Networks and National Grid, and I lead on East Coast Hydrogen for Cadent. So some housekeeping first. This meeting is being recorded, and on questions, the chat function is open, so please do paste questions into the chat as we go through. We'll have a panel session towards the end, and hopefully we'll be able to answer some of your questions then. So I'm going to take you onto the agenda now. So to start with, we're going to have a refresher on what East Coast Hydrogen is, and I will take you through the key phases of the programme. We'll then hear from our speakers on the three key pillars of East Coast Hydrogen. So Dr. Angela Needle from Cadent will talk to us about industrial decarbonisation. Mark Danter from Northern Gas Networks will cover residential decarbonisation. And Tony Green from National Grid will talk to us about interconnectivity. We'll then have a sneak preview on some of the stats that have come out of the East Coast Hydrogen feasibility study, which is ongoing at the moment. And that is prior to our launch of the feasibility study on the 30th of November. And then we'll move on to our Q&A session. And we will hear from our panelists then. And then lastly, we'll cover off some next steps. We've got quite a few people joining today. So I might just give it 1 minute just to allow some of them to come through. Welcome everybody as you're joining today. So firstly, as a refresher on East Coast Hydrogen, or as an introduction to those who've not seen it before, I'm now going to play you a short video. Enjoy.
Hydrogen is essential for us to get to net zero. East Coast Hydrogen is a collaboration between Cadent, Northern Gas Networks and National Grid. Our vision is to bring a hydrogen gas supply to millions of homes and businesses across the east of England by connecting supply and demand, making a vital contribution to the UK's net zero target. We'll do this through developing a cost-efficient hydrogen network by repurposing existing infrastructure that is today used to transport natural gas and building new hydrogen pipelines when needed. Our project will start in Humberside and Teesside, supporting the UK government's ambition for hydrogen production in the industrial clusters. East Coast Hydrogen will connect the two industrial clusters and interconnect with multiple storage facilities to build resilience. In parallel, we will develop gas networks across the east of England, taking hydrogen from the industrial clusters and into the surrounding regions. We will then be able to connect with our local distribution networks, which are ready to accept hydrogen in many areas, and take it into our customers' homes. As production increases across the region, we will support the ability to match supply and demand, providing producers with an opportunity to export their hydrogen. We will initially enable producers to blend hydrogen into the gas network, commencing the decarbonisation of homes and businesses. East Coast Hydrogen will convert millions of homes in the east of England to 100% hydrogen, enabling customers to enjoy the benefits of a gas supply and a fair energy transition. As we expand and connect to other demand points across the UK, the decarbonisation of homes and businesses with hydrogen will bring significant opportunity to the whole of the UK. It will deliver thousands of highly skilled jobs, significant inward investment, and position the UK as a global leader. East Coast Hydrogen is ready to play its role in delivering net zero for the UK and realising the UK government's ambition for building back greener for consumers and businesses.
Super. So lots and lots of people joining through that video. I hope that you managed to keep a track on the thread. We have an awful lot of people joining and beeping away. So I hope that you enjoyed the video. So we're now going to talk about phasing. So we're currently approaching the end of our feasibility stage for the programme. It is a long-term programme, so we're talking about 15 to 20 years. The feasibility study will be launched on the 30th of November, as I said before, and then early next year we hope to move to our phase 1, which will involve pre-feed and feed studies. So feed stands for front-end engineering design. And what this really means is that this is the stage that we will take a look at the detailed design of how we're going to transition our networks towards hydrogen. Also during this time period, the East Coast Cluster carbon dioxide storage infrastructure will be deployed, which will enable blue hydrogen production in the Humber and Tees regions. Then we move on to phase 2. So this is where we start to build out new infrastructure and repurpose existing infrastructure. The national grid transmission pipe between the Humber and Tees will be repurposed, and this will connect together over 7 gigawatts of hydrogen production. On the local transmission side, the network will expand from the Humber region out towards South Yorkshire and West Yorkshire. Now, meanwhile, down in the East Midlands in the Nottinghamshire and Derbyshire region, we're expecting the network to grow out to connect local green hydrogen production, which will be starting around this phase, to the industrial end users. Then moving to phase 3, we would see connection between the East Midlands north towards South Yorkshire, and we would also see connection from West Yorkshire north towards North Yorkshire and out towards Cumbria. Then lastly, phase 4 is about the expansion of East Coast Hydrogen to connect with other industrial clusters where hydrogen production is planned. So connecting all the way over to the Bay of Liverpool, where there's HyNet Northwest, towards Bacton in East Anglia, where low carbon hydrogen production is also planned, deeper into Cumbria, and also north into the Scotia Gas Networks region. So there are about 10 gigawatts of hydrogen production planned in just the Humber and Tees and HyNet alone. And there's obviously the potential to connect up much more volume nationally. So now we're going to hear from our 3 speakers who are going to talk through the 3 key pillars of East Coast Hydrogen. First up is Andy Needle, who's going to talk us through the work that East Coast Hydrogen is doing on industrial decarbonisation. Thanks, Andy.
Morning, everybody. Thanks, Sally. Nice to have you all here today, and I'm really thrilled to see so many people I know joining the webinar as well. So if I know there's lots of hydrogen experts here too, so if there's any tricky questions, we've got to ask the audience a potential response, I think. So I apologise as well. I've got a bit of a cough, so I've got some water with me in case. I'll go on mute if needs be. So let's just talk about natural gas at the for a moment. I know this is about hydrogen, but the UK uses 900 terawatt hours of natural gas. And that's 3 times the amount of electricity that we use. So whilst electricity is everywhere, isn't it? We plug everything in. Natural gas actually underpins our energy system in the UK significantly. And those of you who were at COP the last couple of weeks know how important it is. And if you were motivated emotionally in the way I was by some of the speeches that were there, it's absolutely incredible to have witnessed some of those things. We really do need to move away from natural gas as soon as possible. So we've got a huge challenge, and the East Coast region that's covered by this project has about 7,000 industrial users, large industrial users, using about 53 terawatt hours of natural gas. That's about half of the UK's industrial use of natural gas. So really importantly, we've got to obviously plan a shift away from natural gas, and industries can do that in a number of different ways. Many will electrify, some will use blends of different gases like biomethane and hydrogen, and some will switch entirely to hydrogen. What we must avoid is these industries offshoring because it's easier or cheaper to do it somewhere else in another country where maybe the climate ambition isn't quite as strong. So we do have a jobs urgency here and an economy reason for doing this work as well. The hydrogen strategy set out in August by the government expects about 120 terawatt hours of hydrogen needed by just 2035 across industry, power generation and transport. I'm going to leave Mark to talk about residential use of hydrogen in a moment. So that's 120 terawatt hours. That's quite a lot. And if half of it's in this region, we better get going. We better work out how we join things up and how we make it go where it needs to go. So our role from Gas Networks' point of view is to ensure we have thought carefully about the infrastructure that's needed to take hydrogen from the large and small production centres. This isn't all just about blue hydrogen, it's about green as well. To make sure that the infrastructure there is in good time, right, ahead of need, which is important, because we're building this chicken and egg situation with hydrogen, isn't there? We're building supply and demand at the same time, and we have to do those things in parallel. So our role is to ensure that the infrastructure is there where it needs to go. Excuse me. And it's brilliant that over the last month, both East Coast and HyNet North West have been given Track 1 cluster status. It would have been helpful as well, by the way, that Acorn Scotland were given Track 1 cluster status as well. And I know there are many other large-scale hydrogen production projects waiting in the wings also, which is great to see. But what that means for the East Coast and the West Coast is that earlier hydrogen production will happen and large-scale CO2 capture and storage. And it's a great positive opportunity. And I know there's folks from HyNet on this call here. It's been a brilliant collaborative piece of work, and I hope that East and West Coast will join up with some connectivity in our infrastructure. Now, to get industry going, what we did at HyNet was we started a programme of industrial fuel switching. How do we demonstrate that industry can use hydrogen? What's the best places that it's used for? Which industries is it most suitable for? And we've just completed a piece of work with Pilkingtons, who made their first hydrogen glass, 100% hydrogen. For those of you who want to look that up, that's available online as well. So there's lots of industries that can benefit up and down the region from connection to hydrogen. Now, I know there will be lots of questions in the chat about timelines and about cost effectiveness. And excuse me, it's great to see that government are putting in place production incentive, and what that will do is create a market for hydrogen, because we know hydrogen's expensive today. It needs to go through the same learning curve that we did for wind. It needs to be supported in the early days so that consumers who are switching to hydrogen are not put at a disadvantage for doing so when they are switching to a low carbon fuel. So it's really important that we help BEIS continue to focus on building these business models that support hydrogen production. And it's our job as Gas Networks to make sure that we thought about the connectivity of it, making sure that it is cost effectively deployed, that consumers don't pay more for this infrastructure than is absolutely necessary, and that we look about the assets that are in the ground already, and we repurpose as much of those as possible to transport hydrogen. So I think that's all I wanted to say about industrial decarbonisation. It is absolutely crucial to make sure that we plan the routes effectively for any that. If you are an industrial user on the call today and you think you might be thinking about the opportunity for hydrogen in the future, do get in touch, because we will, through the next stage, the feasibility stage, the engineering stage, we'll be looking at making sure we think about design sizes and things like that. Mark, I'm going to pass over to you.
Thanks, Angie, and for that update on industrial decarbonisation. Morning all. As mentioned by Sally, I'll be giving you an update on the domestic customer side and how we plan to move forward with that on the East Coast. It's an ambitious project, as you've probably realised from the discussions already, and we want to give that vision to move forward with the domestic as well as the industrial. So we've been looking and analysed the area, which is included in a map that Shally put up earlier, and that's about just over 4 million homes in the region, and a demand of about 50 terawatt hours. That accounts for about 17% of the UK domestic consumers, and because of the area we're covering, it's quite a high number of gas consumers. Typically, the UK is about 83%, but on the area we've got, just for the density of the homes, etc., is about 90% of the homes that are currently on natural gas that we'll be looking to transfer over to hydrogen. The plan is obviously to develop that project, but obviously it's linked into the heat and buildings policy decision, which is due in 2026, and we're putting plans in place ready for that decision without actually making any move forward. We will, however, be developing the plans and the feed based on the learning we've already got in a number of projects across the networks. The first one and the current one is obviously the hydrogen homes that we've got between the joint project between ourselves, Cadent and Bays, where we've got the two semi-detached properties up at Low Thornley that running on hydrogen with the hydrogen appliances, the boilers, the fires, the cookers, and the hydrogen ready meters as well. We'll also be linking it to the village trials, which is planned and part of the government's ambition to have a village of between 1,500 and 2,000 properties running on hydrogen. That's planned in 2025. Which are obviously linked into the policy decision, but we'll also be linking in and learning from that when we're doing our front end engineering and plans for sectorisation, etc. We'll also be taking into account the fact that there's more than one option going forward. The EUA are about to release a report on residential heating, and that's looking at the various net zero options for heating going forward, and that includes both natural gas and hydrogen boilers, and the boilers for hydrogen being hydrogen ready, hybrid heating systems, and then air and ground source heat pumps. So that looks at the pros and cons of each, and actually runs several different case studies looking at different infrastructure and the way that the different types of homes across the UK. The government's ambition is also the other one alongside that is the blending. So again, we'll be learning what's been done on high deploy and looking at the rollout of blending to help generate that or stimulate the production of hydrogen. And again, this building on the work that the project's been done with Cadent for the 660 homes at Win Lane. We are trying as much as possible to repurpose, and Tony will go into a bit more detail about the NTS. The advantage we've got in the distribution network side of things is the iron mains replacement program, which has been running for many years now and is planned to run until 2032, is replacing the old iron mains with PE, which the research we've done to date and discussions is hydrogen ready. So that will save quite a bit of infrastructure. Across the UK alone, it's 284,000 kilometres of distribution main. We will, however, have to put some new local transmission infrastructure, which we will be linking either from the NTS, which say Tony was discussing, and also the local industrial clusters that will get the hydrogen to the distribution network where we need it for the demand. In the analysis we've done initially, for those 4 million homes, that's around 9 million tonnes of carbon saving per year, which is equivalent to about 1.2 million cars being taken off the road each year. So as you can tell, it's quite a significant number that this project will deliver going forward. So I'll hand over to Tony, who probably will give us an update on repurposing the NTS and getting the production to the required demand. So thank you, Tony.
Lovely. Thanks very much, Mark. Good morning, everybody. Thanks for joining us this morning. I've just been looking at the chat and there aren't too many questions coming through. So can I encourage you, please, to fire some questions? Otherwise, this might finish very, very, very early at this rate. So hopefully we're stimulating some ideas and we'd love your feedback. So please pop those in the chat. So what I wanted to do is just pick up on the aspects of the connectivity, because particularly East Coast Hydrogen is all about how do we connect supply and demand. And the other aspect from our point of view, many of you will be aware that we are working on Project Union in parallel to this. Project Union is our concept for a hydrogen backbone for the UK. And this is where the two projects absolutely come together, because if you think about the clusters moving forward, we've seen obviously in the last week the track 1 clusters moving forward on the East Coast area and on the HyNet area on the West Coast. You've got the clusters moving forward first. Project Union provides that hydrogen backbone running through the core of those assets, and then we can build out to the regions as Mark and Angie have covered. So what we're very conscious of as we're working through East Coast Hydrogen is bringing the two projects together to make sure that as we look through the lens of industrial decarbonisation, as we look through the lens of decarbonisation of homes and businesses, that we're looking at the common assets to make sure that we are, I guess, fundamentally making no regrets proposals, no regrets decisions, to make sure that under any eventuality, however we look at these, it's working out and delivering ultimately the lowest cost and the lowest risk overall. The other aspect that we haven't picked up on so far is as we build out and start connecting the clusters and then picking up other supply points. Angie mentioned green hydrogen as well will start popping up in different locations. We've also got the links to create then more of a cohesive market. And we also have to pick up storage in this. So when you've got transmission asset running through the core of this, you can start moving some very large quantities of hydrogen to and from the stores. And this is important so that we can actually match the diurnal need, but also the longer term interseasonal need that hydrogen will start to provide. And that's especially if we start going down towards providing power for peaking. So just thinking that through, we want to make sure that we are picking the right assets and we can look at this through any eventuality. So within the Tees and Humber area, we are looking at the potential routing, and there's lots of potential routes that we could take. What we're trying to do is look at what's needed within the East Coast area, but also then what's the bigger picture to go north up into Scotland, to come down into the rest of England, even thinking about what's the interconnectivity needed to connect with Europe. So we've got to look at the bigger picture here in the whole landscape. So there's probably around 200 kilometres of national transmission system sitting within the East Coast hydrogen area. We're going to work through in the pre-feed phases exactly which assets it looks like. We've got to consider the suitability of those assets, the knock-on impact in terms of the resilience of the networks. Bear in mind, we've got to maintain the natural gas network while we are transitioning to a hydrogen network. And that's incredibly important as we make sure we don't leave anybody behind and we allow businesses to move forward and homes to move forward in a suitable time frame. So the key thing is, let's make sure we repurpose assets wherever we can. The costs of repurposing assets are around 1/5 of new build. So that cost is obviously a huge amount if we start having to do new build. So let's try and make sure that we don't go down that route if we don't have to. Now, as regards the repurposing, this is another area we're looking at very closely on some of our other work. Many of you will be aware of, we're constructing Future Grid at the moment. Future Grid is our site up at Spade Adam, which interconnects with the Northern Gas Network H21 system. Future Grid is decommissioning some assets from around the country that have been carrying natural gas for many years. We are going to be rebuilding a test facility up there, so it's going to have a full entry point, full exit point, line pipe, block valves, slam shuts, and we'll be running first of all 2%, then 20%, then 100% hydrogen through that asset. So we're going to be demonstrating at full scale that the NTS assets can be repurposed in that hydrogen world. So as we come to deliver this, this is all about working out how do we get to the right transition. None of us know the exact routes, none of us know the exact assets right now. That's what we're working through as we do this project and as we interconnect with all the other projects. So that's, you know, critically important. We're not trying to do this just in a bubble. We're trying to make sure that we've got this full landscape that ultimately maps out across the full country. And I know there was one question that I saw pop up earlier. What does this blueprint work elsewhere? And absolutely, we're very cognizant that this needs to map onto the other blueprints and that there's a regional approach around the UK. So that's absolutely what we're trying to do. Ultimately, we're trying to maximise the benefit and deliver at the lowest cost to consumers, to businesses, and ultimately play our role across the whole of the UK. So with that, I'm going to hand back to Sally. I can see a number of questions are starting to come through, so my appeals worked, and I'll hand back to Sally. Thank you.
Thanks very much, Tony. So hopefully you can see my screen again, because in a second I'm going to take you through some key stats. But firstly, thanks very much to Angie, Tony and Mark. I think that's provided some really insightful commentary, so thanks very much, and hopefully that gives you a deeper understanding of what East Coast Hydrogen is trying to achieve. So a bit on the key stats there. So the figures on the left-hand side of the screen and in the middle are based on existing gas consumers. So up to 39,000 industrial and commercial sites could receive hydrogen through this programme. And if we were to decarbonise those sites using hydrogen, that would be the equivalent of 11.5 million tonnes per annum of carbon dioxide, which is obviously massive. If you add that to the potential residential abated carbon dioxide per year, that is the equivalent to around 20 million tonnes per annum of carbon dioxide. Now, of course, some of these sites will electrify, but this slide is to show you the potential that East Coast Hydrogen could represent. And you know, we know that some industry, in particular high-grade heat, absolutely need hydrogen to decarbonise. And similarly, on the domestic side of things, you know, some of those properties will electrify their heating, but there are many properties which just aren't suitable for the kind of low temperature heat systems that are out there on the electric side. So this is the potential of this scheme. So as Mark mentioned, there's up to 4.4 million residential properties. And then together, the industrial and residential side of things, that's the equivalent to 110 terawatt hours of energy that's currently being consumed in gas that could potentially be decarbonised through this programme. On the interconnectivity side of things, we've already mentioned up to 7 gigawatts of hydrogen production just in the zone that we're talking about. It's massive. And the 800-kilometre figure that you can see there, that is a total of the repurposed NTS pipeline in this region that we see happening, combined with the new local hydrogen transmission pipeline. Of course, there's, as Mark's told you, there are many more thousands of medium and low pressure pipes that would ultimately be reused within this programme so that we can get hydrogen to the people who need it at the lowest cost. The other thing with East Coast Hydrogen is obviously that to provide that resilience, apart from connecting the Humber and Tees, you also need hydrogen storage. and East Coast Hydrogen will collect up to 12 terawatt hours of hydrogen stored in salt caverns. Okay, so that brings me to the end of my section on stats. I've seen lots of fantastic questions coming up in the chat. I'm going to stop sharing now. And the first question is how does this, oh, in fact, I'm having to go right up to the beginning of the chat. Here we go. Okay, so first question, what is the relationship between your group and CCUS Track 1 winner East Coast Cluster? And Mark, are you happy to take that question?
Yeah, that's fine. Yeah. We're building relationships as we speak with various different industries across that region that's shown, and we're agreeing that kind of links up and collaboration agreements with various different producers, end users, etc., including the winner of the East Coast Cluster. That's obviously focusing on the CO2 pipeline that's decarbonising heavy industry, but that also includes blue hydrogen production. So yeah, we are linking up and having discussions with them as well as other end users and producers.
Super, thank you very much, Mark. And next question for Angie from Tony Smith. He asks, in a similar vein, are there parallel northwest plans for the other Track 1 winner? And by that, I think you probably mean HyNet.
Yeah, so I think I think Tony Green made the point, but just to put a bit of context, you know, we're not developing plans for hydrogen infrastructure in isolation in a little region in the UK. Get gas networks of the whole. We've chopped up the country, you know, into sizable chunks that are manageable. So of course, there's a plan that's developing around the Bacton area, and you'll see something new developing over the next few months on that. In the northwest, we already are doing a lot of the feed work for HyNet already, because that was already developed into a series of phases. So you know, everywhere needs to be thought about, and the challenge is doing it in a way that is it runs things in parallel, so that we and it runs with the demand and the production. So we're not trying to do everything all at once and go ta-da. You know, it's incremental, and I think that's the most important thing here. So yes, we do have plans, and if anybody doesn't feel like they're in the plan and they want to be in, just give us a shout, because there's lots of meetings going on about joining things up right now.
Thanks, Angie. So a question for Tony. Does the 9 million tonnes of CO2 prevention, I think that's for residential related, does it relate to ultimate 100% hydrogen conversion switch or the 20% blend?
I might be a bit pick that up. That relates to the 100%.
Go to Mark for that rather than.
Yeah, that relates to the 100%. Perhaps I wasn't particularly clear in the presentation, but yeah, that's for 100%. So yeah, moving from the blend to 100%, that would be the ultimate carbon saving.
Okay, so thank you, Mark. So a question about blue and green hydrogen for Angie. So how and when do you see the shift being made from blue hydrogen to green? How does that transition fit into these programs?
Well, look, we get lots of questions about blue and green hydrogen, right? And we need to sort of calm down a bit, right? We need hydrogen. We need a lot of hydrogen to get to net zero. We need all kinds of hydrogen except for low carbon, you know, high carbon hydrogen, if you like. So when you look at the plans that the government's made in relation to the hydrogen strategy, they've clearly laid out a twin track approach, and they've done that on purpose because there's so much is needed, and there's loads and loads of green hydrogen projects now. So we've got this sort of blue going to green, but actually I think there's blue and green both starting together. It's just that the blue projects are going to produce larger volumes of hydrogen in the earlier days, but the lowest carbon hydrogen has to be the destination, regardless of how that's made. So I think we need to be, you know, and obviously from an infrastructure point of view, our job is to take the hydrogen where it's needed to go. We're not going to be able to cherry pick you know, different colours of hydrogen that only go into the gas network. So our job is to make sure the network is available to take the hydrogen that's produced, and the government is creating a low carbon hydrogen standard, which makes sure that nobody will be able to get paid the incentive if it doesn't meet very strict standards. And I'm actually really looking forward to see what those are, so that we can make sure that we are definitely driving things in the right direction. So the infrastructure that we're creating in East Coast Hydrogen will be compatible with both blue and green hydrogen.
Thanks, Angie. So we have a question on steel transmission pipe. So I will send this one to Tony. The question is, what volume of steel transmission pipe are you anticipating will be required?
Well, that's a good question. I'm wondering whether that's somebody interested in new pipeline asset, or whether they're asking the question about how much asset overall. I guess the exact split we don't know at this point. If I talk about Project Union in its entirety, that's the overall hydrogen backbone which connects all the clusters. That's approximately 2,000 kilometres. And if you recall, I said there's roughly around 200 kilometres in the East Coast area. Now, the exact split of how much of that is repurposed and how much of that is going to be new build comes down to the exact routings we choose, and then how much connection we need to do into each of those areas. So we are working on the basis that we will repurpose as much as we can. Future Grid, as I said, is proving that we can repurpose the steel mains that we've got. We're focusing on I'll call them the older, more malleable steel pipes first, because that's the majority of our asset base. The higher tensile steels are not actually in the East Coast area. They tend to be in South Wales and some running out of Scotland. So we're working on the potential mitigation measures for those at the moment. So if you look at comparable studies over in Europe, they're looking at roughly 80% reuse, 20% new build, just as a rough rule of thumb. Now that's looking at everything in its entirety, but hopefully that helps give you an idea of the potential splits. But we haven't done the exact numbers here in the UK. I don't know if anybody's seen the Restream report that was published just a couple of weeks ago that was looking at transmission asset across Europe, but that was highlighting that here in the UK we've probably got the highest opportunity for repurposing assets of virtually any European country. So that's quite a useful report if you just want to take a look at that.
Thanks, Tony. And we did just have a quick follow-up question expressing that it was about new transmission pipeline. So could you just make a comment on that, whether you see new transmission pipeline being needed?
I think that will largely come down to exactly what routes are required, how much hydrogen needs to be moved from A to B. As I said, obviously we will use existing pipeline wherever we can. If we find that either that pipeline is not suitable, or the volumes are much higher than expected, or it creates a resilience issue for the existing network, those are all reasons why you might have to look at new asset. But one of the reasons why we're looking at this in the big picture is that we've got a lot of asset out there, and there may be opportunities to route things different directions. So it's very important that although we're working on East Coast Hydrogen here, that we're looking at that bigger picture, and can we provide routes down the West Coast, for example, rather than down the East Coast, to provide the natural gas resilience while we're getting East Coast up and running, or vice versa. So that's why Project Union in its entirety, and why we're doing some very high-end modelling that's proposed going forwards to really understand what is the art of the possible with the current network, and then ultimately try and minimise any new build that's needed.
Great, thank you, Tony. So a question now for Mark about blending. How soon will blending be available so that you can act as a physical off-taker of last resort to de-risk hydrogen production investment?
As I mentioned in the presentation, we're currently doing HyDeploy 2 with Cadent, and we're feeding into about 670 homes in Winlayton. That started in August time. It's a 10 to 12 month trial. Following on from that, Cadent have got the a piece of work where they're looking at a larger area plus more commercial and light industrial. So we're working on the blending to make sure there's no particular issues. I think most people are aware the domestic appliances can take up to roughly 23% hydrogen. That's what they've been designed for, even prior to this work we're doing now. But on the industrial side and commercial side, there's a few more hurdles to overcome. The ambition is, 2023, 2024 that we'll start doing more wider blending.
Thanks, Mark.
Can I add a bit on blending? Because there was a few questions in the chat and they're all really relevant. So there's a couple of things that need to happen for blending. One, we need to be able to demonstrate that when we put hydrogen in the gas network, wherever it goes, whatever appliances are used can take that amount of hydrogen. That's quite important. So there's some people on the chat going, well, actually, I think my industrial process might only be able to take 5%, whereas, domestic boiler next door can take 20. That's really important. So the next stage of the project called Hydroploy is looking at the specifics on commercial appliances. That's really important because that might therefore limit the amount of hydrogen we can add into the gas network. The other question was around using offtakes and blending as a sort of producer sort of spillover. And again, that's important because that means the amount of hydrogen that goes into the gas network will be variable. And that causes problems for the end users. So we have to think really carefully that we are thinking about which places the hydrogen is going to go and what regulations might need to change to enable that to happen and what happens to the appliances when it gets to where it's going. All these things are also being thought about by BEIS, and there's a number of working groups. They do have an ambition by 2023 to have worked out whether it should happen or not. But I think if those of you who have a desire to blend and want to get involved in the consultations and those kinds of conversations on blending and the billing and all the complicated things around it, again, I would get in touch with Cadent or with NGN because we're leading quite a lot of conversations about that directly with government. It's really important. Thanks. Oh, and by the way, we also have a map of best blending locations in case anybody's interested.
Thanks, Angie. Another question on blending, and I'm wondering the best person to answer this. So the question is, how can you provide industry who have variable hydrogen concentration demands using the same grid network, e.g. an end user who can take a 10% blend versus an end user who can take a 20% blend?
Yeah, so that's what I was just referring to. So because the hydrogen will be blended into the gas network, goes where it goes, you would manage to the smallest amount that you can, if that makes sense. I mean, it'd be lovely to put the most hydrogen in that you can, get up to 20%. And by the way, you then have to jump from 20% directly to 100%. But if an industrial user or a particular appliance or set of appliances on the network can only take 5, unless it's upgraded somehow, there will be a difference between, well, is it worth upgrading it to get 20% everywhere, or do we limit everywhere to 5? Mark, was there anything else that you wanted to add to that?
I don't think so, no.
Yeah, okay, just checking.
Super. So there's a really good question in here around training. So is there a program in place to retrain the plumbers who are going to have to be working with hydrogen? Is there going to be a Corgi type alternative? Do we have the skills and the training facilities to do this?
Probably best if I answer that. As part of the High for Heat project that was run by BEIS, EU Skills were engaged to look at the training for the gas safe engineers. And they're about to start another piece of work on that to develop it a bit further. But the idea would be to have a bolt-on hydrogen module to the current gas safe so that they can get trained and be aware of the differences between the two different appliances. In reality, they're very similar. There's a few different aspects that are different, but the idea is that they would be retrained and certified to work on those appliances. and we'd be identifying those appliances as well in the domestic property so that people were aware that they are hydrogen rather than just natural gas.
Great, thank you.
Sorry, sorry, Sally. There was another question about that was about training facilities. There currently isn't any training facilities apart from what is available with natural gas. So part of EU Skills will be looking at the training facilities and any particular requirements that are needed for that as well. So yeah.
Thanks, Mark. So we've got a big picture question here. So whilst you're naturally focusing on the long-term big picture, there are some vital early things this project and your companies can do to enable the growth of a UK hydrogen economy. What do you see as your project's role in creating and connecting storage, offering injection points for blending, offtake of last resort, and connecting up industrial sites in local areas? How soon can these be in place? Angie?
So, I mean, look, yeah, I'll give it a start, because you have to, whilst this project covers a massive geography, and therefore you can say, well, it's flipping ages away, we're not going to worry about that for a while, because she said it's a long-term project. But there's some near-term stuff. These things start with, okay, what's the first thing that we need to do? Where is this sort of small bit of pipeline that we need to install that takes hydrogen from A to B to begin with? Who are the users that are going to make the most of that little bit of infrastructure? How does that then connect up? We have to think big, long-term, about these short-term plans, because what we don't want to be doing is going back and replacing it again in a few years' time because we haven't sized it big enough. So, I mean, and just to give you a parallel of what we're doing on HyNet, the HyNet project has got, in its first instance, first phase, 80 kilometres of pipeline that's taking hydrogen from where it's produced up to a range of industrial users. Just kicking off that project and the DCO process and all of the consenting that's required and the feed work has highlighted an extra 5, 10, 15 industrial users that want to use that hydrogen, and a number of more companies that want to add hydrogen into the network. So starting small is helpful because it creates a focus of intent. So I absolutely agree with whoever wrote that question. Good question. We really do need to, start smaller and grow out. We need to show the ambition of where things will go. We need to make it easy for those who want to use hydrogen and want to make hydrogen to connect with our infrastructure. And we are regulated monopolies, and there's no rules around how hydrogen infrastructure is developed at the moment. So, we're developing these plans on the basis that we're expecting our regulator to support them at some point in the future.
Thanks very much, Angie. Okay, so we've had a couple of questions around hydrogen embrittlement in the transmission pipelines, and also about compressor suitability. So, Tony, could you talk us through that, please?
Yeah, there's a few technical questions there. I'll try and pick up. So I guess the first question is, are we concerned about embrittlement? I'd be wrong to say I'm not, but that is exactly what we are reviewing with the work at Future Grid. Embrittlement is a very technical subject. There's an awful lot of people looking at it right now. It's also very misunderstood. And if you are working with hydrogen in the molecular form rather than the ionic form that you see a lot around chemical processing plants and so on, it's much more stable, and you're at less risk. Now, that doesn't say we are not at risk. What we're doing is looking at what suitable mitigations there are out there so that we can safely run our assets going forwards. There was one question in the chat saying, about particularly pressure of the pipelines, and it quoted 80 to 120 bar. There's no chance of us running the NTS at those levels. Our pipelines at the moment run at a maximum of 94 bar, and the vast majority of the network is below 70 bar. So just to put that one to bed, we're not going to be able to re-rate our pipelines to go up to those very, very high pressures that you referred to in that question. What we are doing, though, is looking at how we can use the current network and mitigate against embrittlement, and that comes down to pressure management. It comes down to being able to, there are some companies in Europe looking at potentially putting very, very small quantities of oxygen into the gas supply. That would be between 300 and 500 parts per million to give you protection against embrittlement. But we're also looking at potential relining measures, particularly for the high tensile steels, to give a protective coating. There's a few quite exciting opportunities there right now. But predominantly the lower tensile, more malleable steels are basically, we believe at this point, okay with hydrogen. Gasunie have already gone live with one of their assets running on hydrogen in the Netherlands, and they're not seeing any issues at all. Indeed, the largest hydrogen transmission network in the world really don't see any embrittlement on their network with molecular hydrogen. So just picking up the compression question, there were two questions. One was looking at how suitable are the current compressors. The chances are the current compressors could carry a level of hydrogen up to a certain blend. Now, what that certain blend is will depend on the particular compressor itself. But some of the OEMs are suggesting anywhere up to 20 or even 30% on some of them. But that remains to be proven. Above that level of blend, it would be swapping compressors out for new compression that is more suitable for hydrogen. Ben Graham also put a question in about, and nice to hear from you again, Ben. I haven't seen you for ages, so thanks for putting your question in there. In network compression, could there be an opportunity for boosting gas out of the distribution network into transmission? I think that's absolutely a possibility, especially if you start seeing distributed green generation occurring around the network. There will be times where that gas is not needed, that hydrogen is not needed in that network, and it could be boosted back up to the transmission level and move somewhere else. So I think we could be looking at a world in the future where you do see, I'll use the term the transmission network being used more as a balancing tank almost, and hydrogen moving backwards and forwards within the networks. And that would basically give us a far more distributed energy pattern rather than the top-down approach that we have today, that natural gas always flows in one direction. So I think you're onto something there, and I absolutely think we could see that scenario in the future as areas develop. Sally, I think I've answered all of those, but come back to me if I haven't.
Okay, thanks, Tony. So,
sorry, Sally, just while you're on, there is actually a project looking at boosting the pressures up a tier rather than keep going down, which is being run by Cadent. So that is something that is actually in flight at the moment as a project.
Thanks, Mark. So the next question, and it also picks up on some comments on use of hydrogen from the grid for transport and deblending. And so the question is, can you provide vehicle fuel grade hydrogen off the grid? Has the process to upgrade grid hydrogen to vehicle fuel quality been proven? And Angie, I think you'd be a good person to answer this question.
Yeah, well, I mean, it's been partly answered in the chat already. So, I mean, if you had lovely new hydrogen production and a brand new gas network, chances are it would get to where it needs to go in good health, you know, being nice and pure still. However, today's gas network has had North Sea gas in it for quite some time, and whatever dust, and I mean, if you slice through a bit of our pipework, you know it's got like a residue, like a film. So even if we put hydrogen in our existing gas network, it would probably come out the other end and not clean enough for a fuel cell. There are projects ongoing to look at the purification of hydrogen when it gets to where it's going, so that it can be cleaned up for use in fuel cells and other applications. And the reason why that's important is that transporting hydrogen around the country by tube trailer would be very expensive in the long run. And we know gas pipelines are one of the cheapest ways of moving energy around. So it does need to be explored. But in the first instance of hydrogen production for transport, you know, you're probably going to have your production being made close to where your refueling stations are in the first instance. But as you know, the network grows, we will be able to to do that. If we can get the technology that works in a cost-effective way, of course, and that's the main ambition. Now.
Super, thanks very much, Andy. So that takes us to the end of our panel session. Just going to bring up one final slide. So there were some questions about how industrial users of gas can engage in this programme. That's a great introduction for the next steps that I'd like to take you through. So for any companies that are interested in using hydrogen, there are a number of options for how you can engage with East Coast Hydrogen. If you're fairly sure that you want to use it and you want to get much more involved with this project, then you can join our consortium group, and there's an email address on the slide there. So please do get in touch. And then also in this vein, we are setting up a users group in the new year for potential hydrogen users that are industrial. And then lastly, if you have any other thoughts or comments or questions, please do get in touch with us on that email address and we can address your queries. So thanks very much for attending today. We're thrilled to have been able to share this with you. We hope you've enjoyed it. As I said, the feasibility study will be launched on the 30th of November, so look out for that. And the only thing remaining to say is thank you very much for joining us today.